Jai Hind to all. I am Komal Rani, from Assistant Professor from IT Department at AKGEC Engineering College, Ghaziabad. So, in this video lecture, we are going to discuss the tree data structure. So, let's discuss the tree data structure of. This is the unit 5th, that is the tree. We in this video lecture we discuss these concepts of the trees, that is what is the definitions, what is the binary tree traversals and binary tree search. Okay, this is the 5th unit of DSTL, that is. And what are the objectives of this unit? So understand and apply the various logic behind the structure to solve the problem, and understand and apply the concepts of graph theory, because we have discussed graph. So 5th unit is a combination of the tree, graph and combinatorials. Okay, so these are the objectives of 5th unit. Okay, so we have to discuss only this in this video lecture. Okay, so tree data structure. So what is tree data structure and where we use it? Okay, so tree is a non-linear data structure. When we have to data, when our data is in the terms of non-linear. Okay, so if you are not able to store the data in the linear form like array, okay, so we have to go for the tree or graphs. So tree is a non-linear data structure, it is not a linear, okay, which organize data in a hierarchical structure. This is the advantages of the non-linear data structure. In this structure you can store the data in hierarchical structure, and this is a recursive definition of the tree. And other definition of the tree, a tree is a connected graph without any circuits, means there is no cycle, okay, but it is connected like this. This is a tree and this is a graph. So here all elements are connected to each other in a hierarchical format. Okay, so when you apply the cycle or the circuits, it will note a tree. Okay, so if in a graph there is one and only one path between every pair of vertices, then graph is called as a tree. So here in this graph you can see there is a two path to go from this, and starting from this and this you can go at this. Suppose this is the vertices 1, this is the vertices 2 and this is the vertices 3. So for 1 to 3 there is two path, okay, directly from 1 to 3 and directly from 1, 2 and 3. So if there is two path exists, that means it is not a tree. If there is only and only one path exists between two nodes, we can say that this is a tree. Okay, suppose this we numbered the vertices 1, 2, 3, 4 and 5. For 1 to 5 there is only path 1 to 3 and 3 to 5. For 4 to 3 there is only one path exists, and for 1 to 2 there is only path exists. So this is the way you differentiate between the tree and the graph. If there is only one path between two nodes, then you say that this is a tree data structure. If there is two path at any point, then this is not a tree, it will become a graph. Okay, so let's hope you will understand about the definition of the tree data structure. So let's discuss some properties of tree data structure. So there is one and only one path. So first property is that there is only one and only one path between every pair of vertices in a tree. Discussed in the previous slides. A tree with n vertices has n minus 1 edges. Suppose there is 3 vertices here. So number of edges is 2. Suppose 4 vertices, number of edges is equal to 1, 2 and 3. 5 vertices, number of edges is equal to 5. So if vertices is equal to n, then edge must be equal to n minus 1, because the root node is common here. Okay, so the third property is that a graph is a tree if and only if it is minimally connected. That is, there is only one and only one path between every pair of vertices, then we say that this graph is a tree. If there is more than one path exists, then we said that this is a tree. Okay, so if one path exists, then we say that this is a tree. If more than one path exists, then we say that this is a graph data structure. So any connected graph with n vertices has n minus 1 edges in a tree. This is the property of a tree. Okay. So there is basically terminology of the tree data structure which we usually use to describe the data structure of a tree. So here we discussed what is root, what is edge, what is parent, child, what are siblings, what is the degree and how to calculate the degree of a node, what are internal nodes, what are leaf nodes, what are levels, what are heights, and what is depth of a tree, and what is subtree and what is forest. So let's discuss one by one. So first of all, discuss the root. So root node is the origin of the tree data structure. So where the tree start, that is known as the root node, and that is known as the origin. So it is always a first node of any tree. The first node of a tree is also known as the root of a tree. If any tree, there must be only one root node, because we know that there is only one and one path from every two node. So from root node, every node is connected, and there is one path for every other node from root node. That's the property how to find this is a tree or a graph. Okay. So let's discuss. This is the root node A, from where the tree originated. Okay. So this is B, C, D. So you can see in this tree that for every two node, there is only one path. That's why it is a tree. The second terminology is the edge. What is edge? The connecting link. Okay. This is a link between any two nodes is called an edge. Okay. So these all are edges between two nodes, which are, or we can say the connection between the node is known as the edges. So the connecting link between any two nodes is called an edge. If in a tree n number of nodes exist, there exactly n minus 1 number of edges exist. So next is the degree. How to find the degree and what is the degree? First of all, so total number of children associated with a node is called the degree. So degree of tree is the highest degree of a node among all node in a tree. What will be the highest node, highest degree? That is known as the degree of a tree. Okay. So here you can see that the degree of node A. So degree is different for different node. For degree A, there is two edges associated with A. So degree of A is equal to T. Here the root from this node, the three edges expand 1, 2 and 3. So the degree of the node B is equal to 3, and the degree of node F. Okay, here no node is expanded. Okay, so here there is no edge outcome from that node. So here the degree is 0, 0, 0 and 0 and 0. What is the degree of C? Degree of C is equal to 2, because two edges are there, and here the degree is equal to 1, here the degree is equal to 2, and this is here the degree is equal to 0, and this is degree of A is equal to rho. This is the way how to find degree of any node. The number of edges associated with the node, that is known as the degree of the node. Okay. Next is what are the internal nodes. As the terms indicate, internals, that is inside. Okay. So the node which has at least one child is called an internal. Okay, internal nodes, that is inside. For inside there must be have two or one child or any child or children. Okay, so we can say that any child, any node which has at least one node or one child is associated is called as the internal node. Okay, so internal node also called as a non-terminus. So these are the terminus node which don't have any child. That means that the path is stopped here. If you move from A to key, you have to stop here. No further path is there. Okay, if you move from A to G, no further path is there because this is the child of a E. It is not a parent of anybody. Okay, so these are the external node, or we can say that the terminal nodes. And what are non-terminal? Which don't terminate. That means which has some child. Okay, either one child or two children. Okay, so every non-leaf node is an internal node. So A has two child, A is an internal node, B has child, B is an internal node, F is the terminal node. So this is not a internal node. Here E is the internal node because it has two children. Okay. G is the internal node and C is the internal node. H, K, J, I, D and F are the terminal nodes. That's why they are not internal nodes. So for internal node, the node must be non-terminal in nature. Okay. So next consider the level. What are the level of a tree? So in a tree, each step from top to bottom is called as a level. So the level count start with 0, increment by 1 at each level or a steps. So for example, here the root node, this is the level 0 because here the tree is originated. Okay, this A has two children B and C at the same level. So this is the level 1. As you move from the top to the bottom, the level will be increasing at every level. Okay. So this is the level 2, this is the level 3 and so on. So always the root node is a level 0 and when we move forward, the level will be increasing by 1. So this is the way how to find the level of a tree. Next, height. This is the important concept. What is height of a tree? The total number of edges that lie on the longest path from any leaf node to a particular node is called as height of the node. So height of the tree is equal to height of the root node. So what is the longest path? That is always starting from the root node and ending at the terminal node or the leaf node, we can say that. So this is the way how to find the height. For example, what is the height of K? That is equal to 0. Okay, this is what is the height of B? That is the 0 height, that is the 1 height and that is the 2. That is equal to 2. So keep in mind that height and level are equal and opposite. Okay, but the only difference is that the level starts from upward, that is level 0, but the height start from the upward direction and level start from the downward direction. So the only difference is that. Okay, so here the height starting from 0, so all the element, that is K height 0, J height 0 and I height also 0. So when you consider any node, that is here H height is equal to 0. Okay, so when we move one step up, height is equal to 1 here and this is the 0, this is the 1 height, this is the 0. Okay, and when we move in one up direction, the height will become the 2. So here the height will become the 2. Okay, but you can see that the height of C is equal to 2 and what is the height of A? That is equal to 3. So if you know, if you refer to the previous slide, okay, like this, here the level is 0 to 3 in the downward direction, but height is also a 3. The level is also 3 and the height is also 3, but the direction to calculating is different. So height is calculating from 0 to upward direction and the level is calculated from root node to the downward direction. This is the only difference. Otherwise, height or level is also always equal in nature. So, next terminology is the depth. So, what is the depth? Total number of edges from root node to a particular node is called the depth of a node. That means, for starting from root node, whatever the level you go to reach at particular node, that is known as the height of a or depth of a tree. Okay. So, for example, we have to reach here k. So, what is the depth? That is equal to 0 to 1, 1 to 2, 2 to 3. So, we can say that the depth of node k is equal to 3. Okay. And what is the depth of b? 0 to 1. What is the depth of e? 0, 1 and 2. What is the depth of j? That is equal to 0. What is the depth of I? That is also 3. What is the depth of f? 0, 1 and 2. And what is the depth of d? That is equal to 2. 0, 1 and 2. This is the way how to find the depth. Okay. So, depth of the root node is also always 0. That's why we are starting here 0. The term level and depth are sometimes used interchangeably because level is starting from 0 and move one level. So, here depth is starting from 0 and move one step in the downward direction. Okay. So, you can because the methods to calculate the level and the depth are equal. So, that's why we can use interchangeably the level and the depth. So, next terminology is the subtree. What is subtree and how to find the subtree? So, in a tree, each child from a node form a subtree recursively. So, how to say that this is a recursive in nature? Because you can see here, this is a small subtree and this is also a subtree and this is also a subtree. So, from that subtree, you will move to that subtree. This subtree is a part of that. That is why we called it recursively. And every child node form a subtree on its parent node. So, this is the parent. So, from that, the two possible, because two edges are coming from the A. So, two possible subtrees are there. Okay. So, here 3 edges are coming from there. So, 3 subtree can be possible if F are terminal in nature, non-terminal. If the F also is terminal in nature and it has something, so this is also a part of a subtree. And similarly, if D has some nodes and this will also a part of a subtree, and the three subtree will make the one subtree, and this combination of this subtree, it will become a complete tree. So, the subtree, every child node from a subtree on its parents. That's why we will say, because F is not a parent of anything, so there is no subtree is there. D is also not a parent of any tree, any node, so that means D is not a subtree, but E is a parent of I and J. That's why we called as a E as a subtree. Okay. So, this is the way you find the subtree. So, next is the forest. So, what is forest? A forest is a set of disjoint tree. So, if you remove this subtree from the root node A and this subtree from the root node B, so this will become a forest and this will also become a forest. Okay. So, because these two trees are the disjoint, there is no common element or no common nodes available. So, that's why we will say that this is a disjoint tree. So, any disjoint tree of a tree, if A has another subtree, so that is also become a forest next. Okay. So, if there is the disjoint means there is no common element or node present in that. So that is known as the subtree. Okay, or that is known as the, from subtree you will make as a forest. So these are the terminologies we discussed here. So let's discuss the binary tree of a tree data structure. So what are the speciality of a binary tree? So binary tree is a special type of tree data structure. Why we will call it a special? Because every node can have at most 2 children. What do you mean by at most? That means maximum 2 children are there, but can be 1 children or 0 child. Okay. So at most 2, that means more than 2 is not possible in any binary tree. So thus in a binary tree, each node has either 0 child, 1 child or 2 children. So this is the example, a node which has at most 2 child. So here that at most 2 child B and C, here at most 2 child. Okay, so maximum 2 child there, but here only 1 child. So we can say that this is a binary tree because at most we will discuss. Okay, so at least can be 1 child can be possible, here 0 child, here 1 child. Okay, so this is a binary tree. So binary tree is a tree data structure which has either 0 child or 1 child or maximum 2 children, not more than 2 children. Unlabeled binary tree. So a binary tree is unlabeled because there is no labeling here. So okay, in the form of 1, 2, 3 or in the form of the alphabets, if there is no labeling is there, that means if nodes are not assigned any label. So number of different binary tree possible with n unlabeled nodes, that is equal to 2n Cn upon n plus 1. Okay. So this is the formula to calculate if there are 3 children. So how many different tree possible here? 6C3 that upon 3 plus 1. Okay. So this is the way how to calculate number of binary tree possible for any number of node. So example, suppose we want to draw the different binary tree that are possible with 3 unlabeled nodes. So this is the formula as discussed, 6C3 by 4. If you calculate the value, that will become the 5. So you can say that with the help of these 3 nodes, you can make different binary tree, that means 5 different 5 tree. So after that there is no possibility to draw the binary tree. Okay, so you can see that there is a, it follow the property of a binary tree, that means at least 0 child, 1 child or maximum 2 children. So this is the way you calculate the how many different binary trees are possible with a limited or certain number of nodes. So next is the labeled binary tree. So if there is labeling are there, that is equal to A, B, C labels are there. That means parent will be here certain A. Okay. Node will be certain, that is B and C. So what are the different way to find, what are the formula? That is 2n Cn upon n plus 1 multiply n factorial. So this is the way 3 labeled node. So when you calculate with this formula, you will find the 30 labeled node can be exist. So how this 30? Okay, so sometime this, if you see, this is the 5 different. Okay, when you labeled this will become the 3 times, 3 times, 3 times, 3 times, 3 times. Okay, so 15s are there. Okay, so if you change the positions interchangeably, 15s are more. So this is the way, the 30 possible way to draw that with the labeled data structure. So types of binary trees. So there are different types of binary tree: rooted binary tree, full or strictly binary tree, complete or perfect binary tree, almost complete binary tree, and the skewed binary tree. So let's discuss one by one. A rooted binary tree. Rooted binary tree is a binary tree that has a root node, and every node has at most 2 children. This is a binary tree, then at most 2 children properties are always there. So rooted binary tree, that means that has a root node. So here A is a root node, and at most 2 child properties are valid here, so that's why it is known as the rooted binary tree. So next is the full or strictly binary tree. A full or a strictly binary tree is a binary tree in which every node has either 0 or 2 children. Okay, so children can be 0 or 2. So there is no 1 children in a fully. That's why we call full. Okay, either empty or full. So here you can say 2 child. Here you can say 2 child. This is 0 child, 2, and this is 1. So this is the contradiction here in the definition of the fully strictly a binary tree. So this is not a full binary tree. This is a binary tree but not a full binary tree or strictly binary tree. But here you can see 2 child, 2 children, 2 children. So this is a fully or the strictly binary tree. So next is complete or perfect. So a complete or perfect binary tree is a binary tree in which every internal node has exactly 2 children and all leaf nodes are the same level. Okay, so that's why every leaf node, here the 4 leaf node exist, 1, 2, 3 and the 4. All are at the same level and every node has 2 children, exactly 2. So here keep in mind exactly 2. So A has 2 children, C has 2 children and D has 2 children. So exactly true condition, 2 children condition exists and all the child node at the same level. We can say that this is a complete or perfect binary tree. So what is the almost complete or binary tree? So almost complete binary tree is that tree in which the last node at the one level, the last internal node can have 1 child. But this node cannot have 1 child. There must be a situation and from left to right you have to draw. So an almost complete binary tree is a binary tree in which all levels are completely filled except possibly the last level must be strictly filled from left to right. Here you can say that this is in the right direction. So the filling should be done from the first level complete, second level complete and the third level. This F must be here and after that if any child, so this comes here. Okay, but here you can say the all levels are completed except the last and this filling the from left to right. So this is an almost complete binary tree. Next is a skewed binary tree. Okay, a skewed binary tree is a binary tree where all the nodes except one node has 1 and only 1 child. The remaining node has no child. Okay, so these skewed binary tree is a binary tree of n nodes such that depth is equal to n minus 1. Here you can start from here 0, 1, 2 and 3. Here 4 nodes are there, depth is equal to 3. So every node has at most 1 child except this last node. Okay, so this is the way you can left skewed because all the trees goes in the left direction and this is the right skew, all the child on the right direction. So this is the way you define the skewed binary tree. So thank you so much. Hope so you will consider, hope so you will understand about what is tree, what is the definition of the tree and what are the different terminology of the tree and what are the different types of trees. Thank you so much.